Hello everyone, welcome to SDL2 on Xcode tutorial. In this project, we're going to build the classical game snake game on Xcode using C and SDL2. And this is the episode 2. In our previous episode, we said that we're going to make this event loop into something called screen management. It turns out that I mean scene management because in this scenario, scene is a better terminology than screen. Now, why do we need scene management? Well, imagine that in your game, you have a lot of scenes. For example, you have the start scene, meaning that when you start the game, you have a scene to select your option to play games. You play option, you have the quit menu, something like this, and then you have the game scene where your game is actually running, and maybe after you finish running the game, you have some game over scene, you have some scene to display highest score. So there are many different scenes, and within each scene, you might have different logic to handle the event, and you might have different update function and maybe render different stuff. So it is hard to put all things into one event loop. And that is the reason why we're going to introduce the scene management within our engine. To do so, we're going to introduce two more files called scene.h and scene.c. Remember that we have our prefix wt in order to avoid name clashing. So in here, you can see the definition of our scene. You can see that this is actually an example showing you how to implement classes using C. And moreover, we can do the morphism using C as well. To do so, we are going to define something called the scene as our kind of like a parent class. And within that, there was some virtual function called scene methods. That means in order to implement a subclass of the scene, we need to at least provide the function defined in these scene methods. And that can be considered as a virtual function associated to the scene. These virtual functions include the init function, clear function, handle, event, update, and render. You can see that these three functions actually corresponding to what we have done in this event loop. And what about the init function and the clear function? Well, the init function is used to initialize our scene, and the clear function is used to clear up the scene. And that is our scene methods that we need to implement. And let's look at our parent class scene. So in order to be a subclass of a scene, we have to use this wscene head at the beginning of our structure. And that is usually how we do inheritance in C. Now, once we have a structure that with this scene head, that means it will have automatically have a name field and also a method field. Then if you have, say, you have a scene called scene, then in order to initialize it, usually you will do the following. You method, and then you go to the init function, and then initialize itself. You will do something like this. And you can do the same thing for clear, handle, event, update, and renderer. And because this is so common, we're going to define some API or some function to do this for us. So for example, this init function actually did what I just did here, which we will call basically do scene and then methods and then init and then scene. That is what basically this function does, and return this. Of course, it does more than this. It will check whether the scene is null, or whether it has the methods, or whether it has the init function. Let's go to the definition and see what it actually does. You can see that here at the beginning, we're going to check that whether our scene is a valid scene and whether it has the init function. If it doesn't have it, then it returns false. Otherwise, we're going to call you can see call the scene method, the initialize method on itself, and then get the return code. And then we do some logging and then return. So we do the same thing for all other functions. You can see all of these functions follow the same pattern. We check whether or not the function exists and then call the function on itself. And that's how we do morphism in C. Next, let's see how we are going to put this into this event loop in our engine. To do so, we are going to add more functionality to our engine here. To be more precise, we are going to create some simple loop in our engine. In here, the most important thing is that we need to set the scene to our engine. If we do so, then it will have, from this scene, we have the function to handle events, we have function to handle update, and also the render function. They are all from this scene. And then some getter for the scene, and here the frame per second we will leave it for now, and we'll deal with it later. And then we have a function that will start the event loop called engine start loop, and also a function that will exit the loop. Let's see how we're going to implement this set of functions. You can see that in order to introduce this event loop in the engine, we're going to need four more fields. The scene that we're going to use, whether or not we should create the event loop, frame per second that we're going to talk about later, and that is related to the frame per second as well. Now let's go to the definition of the event loop. Oh, by the way, let me show you that we have some initialization for these new fields as well. Let's go to the event loop now. The event loop is in here. You can see that that's how we start the loop. First of all, we check that whether we have a scene. If we don't have it, we just quit with a warning message saying that there was no scene set. Otherwise, we are going to enter the loop. First of all, you can see that we are going to handle the event. If we compare to the main event loop here, the loop are exactly the same. But now we handle the event, update, and also render using the functions from the scene. So let's go back to the engine. Now you can see that we handle the event. We kind of like dispatch the event into the scene, and then we update our scene, and then we render. Before we render, we were going to reset the renderer. In this case, we are just basically set the renderer to render to the screen, and also set the draw color to black. And then we will clear the renderer. That means we will now have a default black background. That's what it does. And then next, we're going to render the scene using the function from this engine.scene. Finally, we are going to present whatever we have by this engine.scene. And that's how we are going to use this scene management. Now, in order to use it, let me create something called app, new file. I think I have that. I'm going to call it app, and then I'm going to include the header files as well. Let's click next, and then create. And that will give us two files, app.h and app.c. From here, we are going to create our app. So let me say wtScene. Now, for now, I'm going to give only one function, app get scene, that will return the main scene of the application, and then we will set the engine to have this scene, and then enter the event loop. Now go to here. For this one, since we are going to develop a lot of scene later on, I have already set up a code snippet that is called the SDL2 wtScene. Let me drop it here, and it will have all the things we need to create a scene. You can see that we are going to define a local scene type. This structure is local in the sense that we can only see this scene within this file, and other than that, other file cannot see this structure. And we have some static files as well, and you can see that the screen method is initialized to be these 5 functions, as in here. Then we are going to define our local scene type as a subclass of the scene using this scene head. Now, and you can see that here there is a scene instance that we have. We are going to call it an app scene, and then the methods is defined to be these 5 methods here, and there are 5 methods that we need to implement in order to add functionality. So this one I call it app get scene. So, and that's it. That's how we start up the loop. But for now, let's say we're going to handle the what kind of event we are going to handle. As inside our main function, we are going to handle only the SDL quit event. So let me go back to here and then implement this one. Now I'm going to use Swift to depending on what kind of type we have, and if we have a SDL, we have a SDL quit, then we're going to quit the event loop. In order to quit it, we need to include also the engine, so that we can use, now we can use wt engine exit the loop, and that will exit the event loop. Now, that is the only event that I'm going to handle in this case. And let's see how we are going to use this scene in our app here. So instead of doing this, we're going to delete all this one, and then we say we are going to get the app. So that means I'm going to include the app header, and then we will get the app scene using the function get scene. And then before we are going to use it, we are going to initialize it. Remember that the initialization will return a boolean indicating whether it is successfully initialized. So we need to check that. If wt, we are going to initialize our app. If it is initialized correctly, then we're going to let our engine to have that as our scene, and then we go into our loop. We are going to start our loop here, and after we finish that, we need to clear up the memory claimed by this scene, and that pretty much is, and that is the function or the new event loop look like this. Let me take a look at the result, and that is our result. And you can see that instead of using the event loop explicitly, we're going to pass a scene into our engine and then start the loop. Then when we try to implement the different render function, different update function, we are going to implement it in our app.c. And if I would like to change the scene, what should I do? Well, there are 2 ways to do it. For example, we can use this wengine set scene to set it to another scene, and then our engine will automatically switch to another scene, right? So that will be done later on when we have more scene. But for now, let's try to do some fun stuff in our render function in here. You can see that for now we have a black screen here, and you can also see that in the debug panel, you can see that our app scene is initialized, return 1 meaning that it is successfully initialized. And after we click this clause here, we quit it, and you can see that we will have the app scene that will clear. That means we clear the memory claimed by this app scene. In this case, we don't need to do anything because there was no memory claimed by this scene instance here. Now let's try to add more stuff to the screen. For example, let's try to say we would like a white background. So how can we do so? Well, we're going to first of all, we're going to get the renderer. Get renderer, and then we're going to set the render draw color to say white. Renderer. White means 0 RGB, and then we're going to be opaque. So I'm going to have 256 here, and then we're going to clear the renderer, and that will give us the white background. Let's check. So you can see that we don't have the white background. What's going wrong? Let's go back to the engine and see if we do it correctly. We have we cleared the engine with reset, and then we render the scene here, and then we present the scene. I think we do it correctly. Do I do something wrong? Oops. Here, I think white is 256, 256, and 256, while I do 0, 0, 0 here. So that is the problem. Now I should fix it, and now we should have a white background. Let's check. Good. So everything worked. Let me add more stuff to it. For example, if I would like to draw a, say, a red rectangle, then I'm going to set the color first. Renderer. Red means that R should be 256, and for the other one, we're going to set it to be 0, and for the alpha channel, we can set it to be 256 as well. Now we're going to define where we should draw the rectangle using this. So let's say we draw it at x coordinate 10, y coordinate say 30. So next is the width. Let me set it to 100, and for the height, let's set to 20. Now, in order to draw it, I'm going to call a function render fill. And then we're going to put in our renderer and then our rectangle to draw. And that should give us a red rectangle on the screen. Let's try to check it. You can see that now we have a red rectangle here. You can imagine that if we would like to have more stuff, we just need to add more code in this render function. And if you happen to have some memory claimed by this structure, then you might need to do some clear up the memory claimed by the structure. And if you have your game updated, you should add more code in the update function. Finally, if you want to respond to more events, for example, the keyboard, then you need to add more code in here. And that's how we manage the event loop. And later on, we are going to add more scenes. For example, we will have a start scene showing the option for us to play. And then we have a game scene for us to play the game. And maybe we have a game over scene to display a message after we fail or we lose in our game. That is for this episode.